In this part of the unit electrostatics, you will learn about capacitor and its capacitance. You can see these are different kinds of capacitors. These are fixed up in electronic devices as shown in these two diagrams. These all are capacitors. Now, what is electrical capacitor and why it is used and what is its capacitance? Capacitor is a device which is used to store electric charge, and hence electrical energy. But charge is stored by conductor also. How this capacitor is different from conductor? Actually, capacitor is a modified form of conductor. From conductor only we make this capacitor. To understand the concept of capacitor, we charge a conductor by an amount Q. Suppose if Q charge is given to a conductor, if it raises its potential by an amount V, then what happens? This Q is directly proportional to V. From this graph also we can see their linear relationship between charge supplied and potential raised in that conductor. It is linear. This proportionality sign is converted into equality by multiplying it with a constant which is called capacitance of that conductor, denoted by C. By this relation C is equal to Q by V, we can define the term capacitance of that conductor. Actually, it is the ratio of charge given to that conductor and proportionate raise in its potential. It is defined as the ratio of charge given to the conductor to the increase in its potential. What will be its unit? Its unit is coulomb per volt, which is also called as farad. Actually, farad is very large unit of capacitance. In general, we use picofarad, nanofarad and microfarad. On what principle this capacitor is based? A single conductor can store only a small amount of charge. If we increase the charge storage capacity of a conductor, we will have to increase its dimensions. Its size is to be increased, which will make it very bulky and it will be inconvenient. So, what is alternate arrangement? Is there any alternate arrangement also to store maximum amount of charge in a conductor? Yes. What is that alternate arrangement? For that we place another identical uncharged conductor near the charged conductor. Like this. It is first conductor which is being positively charged, which is placed on insulated stand. Positive charge is given to it. Let this charge given to this positive this conducting plate raises its potential by an amount V. An identical uncharged plate is brought near it. You can see what will happen due to induction. Its closer side of this second plate will be negatively charged and the farther side will become positively charged, like this. Now this negative charge will lower the potential of first plate, because this is negative charge, this was positive charge. Because of this negative charge, its potential will be lowered. And what about this positive charge? This positive charge will try to increase its potential. This positive charge will try to increase the potential of first plate. What will be the net impact? Net impact on the potential of this first plate will be that its potential will be lowered. Why? Because this positive charge is at a larger distance in comparison to this negative charge from this first plate. The distance of negative charge is lesser from first plate than the distance of this positive charge. So impact of this negative charge will be more. So its overall potential is lowered. What can we do? By lowering the potential, what will happen? We can supply additional amount of charge to it, so that its potential could again become V. By lowering potential, we have enabled this conductor to store greater amount of charge in it. Now, is there another scope of improving its capacity to store charge? Yes, by eliminating this positive charge, by earthing this second plate, we can further increase its charge storing capacity. Now this positive charge, which was increasing its potential, is eliminated by earthing this second plate. It is earthed. This positive charge has entered, means is neutralized by the electrons coming from the earth surface, and this negative charge is bound charge. It cannot leave. So what is net impact? Net overall impact is its charge is, the charge storing capacity is increased and its potential is further lowered. A potential is lowered, further charge can be supplied to this first plate. So this, once again we can understand this concept. This is first plate, second plate, this plate is earthed. So this arrangement is called capacitor. It stores maximum amount of charge in this arrangement. Maximum amount of charge is stored. This arrangement, which is modified form of this conductor, is called a capacitor. So what is the principle of capacitor? The principle of capacitor is that the capacitance of a conductor can be increased by bringing an uncharged and earthed conductor near to it. By bringing an earthed and uncharged conductor near a charged conductor, we can increase the charge storing capacity of the charged conductor. Now let us understand how much charge is stored by an isolated spherical conductor. What is spherical conductor? Spherical conductor is assumed to be a capacitor. It is equivalent to a capacitor whose another plate is at infinity. Let us take R as radius of that spherical conductor, and if Q charge is supplied to that spherical conductor, whether that is solid or hollow, that charge will spread uniformly on the surface of that solid conductor. You have already studied this. You can see Q charge is spread uniformly on its surface. Radius of this spherical conductor is R. We have to find its capacitance. It is a capacitor. Actually it is a conductor. It is assumed to be a capacitor whose another plate is kept at infinity. Now we have seen in the first chapter of this electrostatics, electric field intensity can be defined as the negative gradient of electric potential, means dV by dx is electric field intensity. So inside the conductor, electric field intensity is 0. You have learned this. If E is 0, this is only possible when V is constant. So V, the electric potential on the surface of this spherical conductor as well as inside the conductor is same, that is constant. Its value will be same as on the surface of this conductor, that we will calculate. How much will be the potential on the surface of that spherical conductor? V is equal to 1 by 4 pi epsilon naught Q by R. The conductor is placed in free space. So capacitance is charge supplied by potential raised. Q by V is equal to C. Put up the value of V. We get C is equal to 4 pi epsilon naught R. This is the capacitance of that spherical conductor. If this conductor is placed in a medium of dielectric constant K, having dielectric constant K in that medium, if it is not placed in free space, then this will be modified as C is equal to 4 pi epsilon naught K into R. Epsilon naught K is equal to epsilon, where epsilon is permittivity of that medium whose dielectric constant is K.